A lot of the things I had been mentioning before are kind of foreshadowing now, as I had been mentioning even and odd functions in the last couple of videos. So now we're going to go ahead and take a look at those. We're also going to determine when functions are increasing, decreasing, or constant. We'll talk about relative max and mins for functions. We'll also discuss symmetry and how that's related to even and odd functions. We will also describe piecewise functions and finally do the difference quotient, which is something that you'll see again definitely in calculus. So what does it mean to be an even function and what does it mean to be an odd function? So an even function means that if I plug negative x into the function, I get back the same result as though I plugged in x. So for instance, if I plug in -2 and I plug in 2, both of those equal the same number, let's say 5. If you think about that, right, the 2 points then would be -2, 5 and 2, 5. That creates a symmetry, right, for the x values are the same, but opposite in sign, and the y value is exactly the same. So this creates a symmetry about the y-axis. So let's look at this example down here. Function f of x equals x to the 4th minus x squared. Notice there's the point -1, 0 and 1, 0. And the graph, if we split it down the y-axis, right, and we're to rotate, say, this side to this side, it looks exactly the same. Okay, so that has symmetry about the y-axis. What about odd functions? Well, to make a function odd, well then this time you have to plug -x into the function, and that has to be the same as if you plugged regular x in but took negative of the whole thing. Okay, and we'll get more into this when we're doing it analytically. Graphically, that means that it should have symmetry about the origin. So what that really means is if I were to take this section down here, right here's obviously the origin, and I flipped this piece up here first, right, it would look something like this. And then I flipped it across that axis, right? So I'm flipping it this way first, and then this way second. Then that would give me this piece. Okay, so that's even versus odd. So the first thing we're going to be asked to do is it says here, without graphing, determine if a function is even, odd, or neither, and then describe the symmetry. Well, we really just need to say, is it even, odd, or neither? If it's even, it has symmetry about the y-axis. If it's odd, it has symmetry about the origin. Neither, we can't say anything about symmetry. And in order to test, we need to do the following. We need to plug in -x, and if we get the same thing as the original function, it's even. And if we plug in x and then put a negative in front of the whole thing, and that's equal to f of -x, well, then that's also going to be an odd function. All right, so let's go ahead and try this. So we have a function. First thing we need to do is plug in -x. So everywhere I see an x, I plug -x. -x squared is x, -x times -x, which is really positive x squared. So you'll notice that f of -x here gives back x squared minus 2, which is the same thing as the original function, f of x. Therefore, this is an even function. And if we're asked about the symmetry, then we have symmetry about the y-axis. And again, if we think about this, right, it does say without graphing, but now that we've went ahead and done it, this function, right, is a parabola that's been shifted down 2 units. So it would look something like this. And so it's pretty easy to see that the symmetry is about the y-axis. Okay. All right, let's try another one. So I have g of x here. Another thing I might point out, notice that the power up here is x squared. That's a even power, and that became an even function. So notice we have odd powers here. So let's see what happens. So g of negative x, right? We plug negative x in first. So negative x to the fifth plus negative x cubed plus a negative x. Well, a negative number to an odd power remains negative. So this is minus x to the fifth minus x cubed minus x. This is clearly not the same as the original function. So this is not even. We continue by doing negative of the original function. So negative of everything, which was x to the fifth plus x cubed plus x. If you think about it, right, that's really like a -1 that we're going to distribute to everything in there. So this becomes minus x to the fifth minus x cubed minus x. So notice now that these two, right, g of negative x and negative g of x are equivalent, right? These two things are exactly the same. Therefore, this is an odd function, and it has symmetry about the origin. Okay. So again, we had all odd powers there. That turned out to be an odd function. Here we had even powers. Got to be a little careful when you add numbers, right? If this was x to the fifth plus x cubed plus x minus 3, that's going to cause a problem. That's not going to be an odd function any longer. So there's a bunch of little intricacies to these that we have to keep in mind if you want to kind of, do it in a shorthand. And actually, D is going to prove that to us here. So actually, let's go ahead and jump down and do that one first. I just mentioned it. So this looks almost identical to the one we had before. It's x to the fifth plus x cubed, but this time it's plus 1 instead of plus x. So these two things are odd powers, but then we have a constant, okay? So let's do j of negative x. So that'd be negative x to the fifth plus negative x cubed plus 1. That's minus x to the fifth minus x cubed plus 1. This is not equal to that. So this is not even. All right, so let's see if it's then an odd function. So I need to do negative j of x. So that'd be negative of the whole thing, which distributes a -1 basically to the whole set. This would be minus x to the fifth minus x cubed minus 1. Again, these are not equivalent. So this is also not odd. So we would just say neither. Okay. All right. So let's go back up to C here. And we need to think about what the absolute value function does. So absolute value of x. So remember, we need to do h of negative x, which is absolute value of negative x plus 1. Well, if we do the absolute value of negative x, that's really going to be -1 times x inside the absolute value. And another way to think of that is the absolute value of -1 times the absolute value of x. And that's because, right, the absolute value function is always going to take and turn the thing into a positive number. It tells us the distance from 0. So the -1 really doesn't do anything inside there. And then if x gets plugged in as just some number, we get back that number. and the absolute value of -1 is just 1. So we get back absolute value of x. And that is in fact telling us that this is equal to our original function, and therefore this is even and has symmetry about the y-axis. And absolute value function, and then it's shifted up 1 unit, it's going to look something like this if you wanted to plot it in your calculator. Okay. All right, so that concludes that section.